Hello, this is video 2 of this 3-part series on visualizing and interpreting scatter plots and data in R. So we're going to go on to talk about regression tables. It's just going to connect that visual that we saw in the prior video to the output that we see for the statistical summaries. So we're talking about regression tables, and we're going to connect that to the visual intuition behind regressions. So we've got the graphic that is for that first top left panel of Anscombe's quartet. That's y1 plotted against x1. And here we have that the equation y is equal to beta x plus c, in this case, is best estimated for this data set by the equation y1 is equal to 0.5000909 times x1 plus 3.0000909. Now that is saying that a 1 unit change in x1 is associated with a 0.50009 unit change in y1. So you can see that visually in the middle graphic. You can also see this in the table of results on the far right. This table of results on the far right is how we'd often view it in a professional publication. This is saying if we look at x1 against y1, this column that's highlighted in green, we see that the slope is 0.500. It's truncated. We don't include all of this, the digits, because I don't actually need to know what's happening at the 5th significant digit out from the first decimal point. So the slope is 0.500, the constant term is 3.000, and we've got additional information in this. Namely, we've got some stars on this chart, and we've also got a number in parentheses. Both of these two things are going to represent our estimates of uncertainty. Uncertainty is an absolute foundational portion of statistics. Statistics is designed to quantify and capture uncertainty and tell us how confident are we in the true slope of the lines that we estimate in the statistics that we output. So how confident are we that 0.50009 is actually the slope of the data underlying this graphic? Quick note, we've got 3.0000909. That is the estimate for the y-intercept. So if we extended this graphic all the way over to the left to where x1 is equal to 0, the regression line intercepts x1 is equal to 0 at the y1 value 3.0000909. But let's go ahead and talk about this uncertainty. Uncertainty in statistics is extremely commonly misinterpreted, but extremely foundational. And we've got the stars in the table that indicate uncertainty. The more stars that you have, the less uncertain you are. So the more stars that you have in a regression table, the more you believe your results are not 0. Now that's a funny thing. We do end up always comparing our regression results against 0. Having a slope of 0. And that's a funny assumption. It's actually more reasonable than it might appear at first glance if you think about it, but it is an assumption that is worth keeping in mind as you analyze regressions. So we have stars on this first estimate of 0.500, which means that we believe that this estimate is truly positive. Why do we believe it's truly positive? Well, one way to visualize this is to draw a line within this gray bar. This gray bar indicates the uncertainty in the model. It's a 95% confidence interval for the best fit regression line. And that basically means that we believe that the regression line is at the shallowest, the orange line, which is the shallowest line that you can stick within this gray bar, and at the steepest, the green line, which is the steepest line that you can stick within the gray bar. So we believe that the true slope of this line ranges between the slope of that orange line and the slope of the green line with 95% confidence. We usually use 95% confidence intervals to capture a reasonable sense of certainty, although it's certainly not the be-all and end-all of metrics. So another way to interpret this is to say that I can't fit a straight line through this gray bar. There is no way to put a straight line within this gray bar. And that means that it is impossible for the It's not impossible. We're 95% confident that the best fit of this line is not best represented by a flat line. So that's the end of this section. The next section is going to be caveat emptor, let the buyer beware, the limitations of regressions and interpretations of things like stars on the table.